Hello, today we're going to look at the special similarities day 2, and there's a special situation that happens when we have a right triangle and we draw a segment that creates two more right triangles. If this is an altitude, then we have three right triangles. Now this says measure every segment and try to figure all this stuff out. I'll just measured them here. 5.8, 10 centimeters, 11.7. I don't know if the printer was exactly the same this time. It might be a different format, but let's say it's pretty close to that. Now, if we do that, we can draw a large triangle, and this one's drawn slightly different than the one in your packet. That's this triangle here. There's the medium triangle, BCD, and then there's a smallest triangle, BDA. Now, if we label the information that we have, 5.8, I can just write this in, it'll be quicker, 10, 10, and oops, for the large, and this large triangle is 11.7. Now for the medium triangle, I have two sides, 8.7 and 10. And for the small triangle, we have 5.8 and 3. Now, we could find BD2 by measuring it, or we could use Pythagorean theorem to find it. But what I wanted to see is if I took 11 divided by 10, you'll get the same number. 10 divided by 8.7, you'll get the same number. These are going to be similar triangles, and so is this. And the reason is because if I look at this previous slide with not so much stuff on it, if I take this angle and say this angle is x, if I have 90x plus this equals 180, this one would be 90 minus x. And if this angle is 90 and 90 minus x, this one would have to be x, and this one is 90 minus x. So all three of these triangles have the same angles. So since they have the same angles, all three of these are similar triangles. So they're similar, all the angles are the same, all of the sides are proportional, so we have similar triangles. Later on, I'll do a problem at the end that shows how you can use these properties in an actual problem. Now, there's another property that isn't really involved with the similar triangles. It's always taught in this chapter because you're using ratios, but it has to do with the angle bisector. So if I have the angle bisector, it cuts this opposite side into equal ratios. So if I look at this, A over P is going to equal B over Q. Now we could measure, if we were going to do this in class, what I'd do is have you measure A and P, B and Q, and try to find which ratios match up. But this is the main idea here. So this property is the angle bisector of a triangle divides the opposite side into two segments, whose lengths are the same ratio as the lengths of the two sides forming the angle. So for instance, if I have a situation like this, if I want to find the value of x, I just take 8 over x equals 12 over 8, cross multiply 64 equals 12x, and it equals 5.3. Now if I have this one, x over 51 equals 40 over 34, or we could do 40 over x equals 34 over 51. Forgot how I did it. Both ways are acceptable. Divide and you get x equals 60. This one gets a little tricky. This one, there's both an x and a y, and what most people do is 5 over x equals 8 over y, and you can't solve it. But there's this lurking 10. We got to figure out what we can do. If this whole thing is 10, and this section is y, we can say this side, you can just scratch out the x, and that's going to be 10 minus y. So now we have both of them in terms of y, so now I can set up the ratio. 8 over 5 is equal to y over 10 minus y. Cross multiply. And then put our values together. And once we find y, we just plug it back in and take 10 minus that to get our x value. All right, one last problem, and this is the one I told you about in the beginning. Uh, it's uh, if we have this situation, and we know these are all right triangles, and I should have marked these with right angles, we want to find the value of x. To do so, it helps to draw out these triangles. We have the big triangle, 6, 8, 10. We have the medium triangle, which is x and 8. And really, that's all we need. We could draw out the smaller one, but if we're just solving for x, that's all we need. So the largest side in this triangle, the hypotenuse, is 10. The hypotenuse in this one is x, or is 8. So 10 over 8 is going to equal, now we have to think about this. Is this the largest side in the medium triangle or the medium side, or the medium side or the shortest side? It looks like this is the shortest side. So it's, x is going to match up with the 6. So 6 over x. So now we cross multiply and divide. 48 equals 10x. Divide by 10, and x is going to equal 4.8. And there you go. Hopefully you can do the rest of the homework.